All right, so this video will have questions 1 through 5 from the test review. All right, so let's go ahead and begin by looking at 1. 1 is asking whether or not it is a function. So again, these are the questions from the review that are online. And it says, is the relation a function? Basically, is it passing the vertical line test? So a good way that you can do this, besides memorizing rules, is to graph these points. So if we were to look at, let's say, 6, 12, okay, and then we had like 8, 7, then we had like 3, and I'm just kind of ballparking this, 3, 4, and then we had like 4, 12, then we had over here 8, 6. So this one was 8, 7, and this one was 8, 6. So all of these, if I had a vertical line and I was kind of like scrolling left to right with a vertical line, these would pass the vertical line test except for here. This is where we would have two separate y values that would be given as an output from that same input of 8. So notice on all of these, if you looked at the inputs, they're all different except these two are the same. Okay, and if they have the same output, they're basically saying at the same x value of 8, one y value is a 7, one y value is a 6. So it would fail that vertical line test. So because it does not pass the VLT, this would not be a function. Okay, all right. So let's go ahead and move on. So now let's go on to. Oops, let me get an eraser. We're going to kind of like scroll through, kind of move stuff around as we go through the video. But nonetheless, we're going to do these 5 videos in this one, or these 5 questions in this one video. All right, so let's go ahead and move on down. And let's look at number 2. Number 2 says, find the domain and range and intercepts of the function given. Okay, so we have this function right here graphed. And what we would want to do, just to make sure that we get good practice, is factor out this 4. And you're basically dividing it out from both the 4x. So picture like the 4x and that 2. You're dividing a 4 from each of them. So this would just go to x, and this will go to 1/2. Okay? And this is going to be what you would need to do as far as factoring that coefficient of that x term, otherwise that b value. We're trying to get to a positive 1 the way we've discussed throughout the unit. Okay? Because yes, if you wanted to redistribute it, you'd get 4x plus 2, which is the original piece in the absolute value sign. But now with it factored out, you can actually interpret these transformations, starting with, remember the order is BCAD. And we see this 4, and this is just extra practice, is the horizontal compression by a factor of 1/4. Then we see this shift right here, which would be a horizontal shift 1/2 units to the left, because it's opposite. Everything with the x is opposite. Everything with the y, we follow the rule. Okay, and then last but not least, this 6 would be a vertical shift 6 units down. So you notice my original vertex of 0, 0, not only did it move 1/2 to the left, but it also moved down. So this would be like a negative 1/2, negative 6 as a vertex point. Okay, and yes, the graph does go up and to the right and up to the left. And if we wanted to see how much it actually, what's the slope here? Okay, let me show you that. This slope going here can be calculated by looking at this b term right here of 4, because it's a horizontal compression by a factor of 1/4. So we're used to the slope being positive and negative 1 on a default y equals absolute value of x. But because of this horizontal compression by a factor of 1/4, instead of going up 1 over 1, this one's going to go up 1, but to the right, it's going to go 4 or 1/4. So it's going to go up 1 is like a positive 1. To the right is a positive 1/4. So what we're looking at right now is 1 divided by 1/4. Okay, so 1 divided by 1/4 is the same as what you learned in 5th grade, keep, change, flip, 1 times the reciprocal of this one, which gives you a slope of 4. And that makes sense because if I look here, I'll go up 4 over 2, up 4 over 1, up 4 over 1. And it does have a slope of 4, okay? And then this one's going to be the same, but it's going to be a negative for this slope right here. So again, I just wanted to show you that mathematically so you could see how you could determine the slope still even from the B term. It doesn't have to necessarily be the A term like a vertical stretch or compression to interpret that slope. Okay. All right. So now looking at this graph, we know the graph, the domain is all real numbers. Let me just write that here at the bottom. So we'll go through, we'll list them all out, and then we'll see which one's the answer, A, B, C, or D, whatever. So it's all real numbers, and the range, basically, it starts here and goes up. So its lowest y value is -6, and then it goes up to positive infinity. So you could say -6 to positive infinity, or if you wanted to do it as an inequality, y's that are greater than or equal to -6, okay? Now we're going to go to the intercepts. Okay, so the y-intercept and x-intercept. So if I'm looking for the x-intercept, I'm basically asking myself, when is y equal to 0? Okay, and if I'm looking for the y-intercept, I'm basically asking myself, when is x equal to 0? So I think the y-intercept is easier to get because I can just plug in 0 in to my original equation for x. So in my original equation, I'm just going to plug in 0 for x. So we get 0 times 4 is 0, plus 2 is 2. The absolute value of that is 2, and 2 minus 6 is a -4. So we'll say y is equal to -4 or 0, -4. Either way, that's going to show us what our y-intercept is. The x-intercept is a little bit different. Okay, so the x-intercept is when is y equal to 0? Okay, and y in my original equation is f of x. So if I plugged in 0 for f of x, I'd have 0 equals the original equation, okay, which is 4x plus 2, then minus 6. And from here, we're just going to do calculations the way we've done all unit. We're going to add 6 over so we can isolate this absolute value sign. And now when we've isolated the absolute value sign, we're going to break it into 2 equations. Okay, and the 2 equations, let me make some more room for myself right here. The 2 equations that we're going to do are the plus and minus versions of what we see. Okay, so let me go ahead and set that up real quick. It'll be 4x plus 2 and 4x plus 2. We're going to set it equal to the positive version of the other side, which is just 6. And the negative version of the other side. Okay, so there's no inequality here. Okay, so there's no inequality as far as that was originally given to us in the original equation. And when I'm saying that, I'm talking about an inequality symbol that's right here. So we don't have to worry about flipping anything. We're just going to solve it out from here. So if I subtract 2, I get 4x is equal to 4. If I subtract 2, a negative minus 2, it's going to be a -8. So this one's going to be x is equal to 1, and x is equal to -2. So again, these are the x-intercepts. It's when y is 0. So another way I can write that like a point would be 1, 0, and -2, 0. Okay, so now I have my domain, I have my range. Let's go ahead and look at our answer choices and see which ones work and which ones don't. Well, I know that it's going to be greater than or equal to 6. And right here, I don't have an equal sign. And I don't have an equal sign here as well. So I know these are not going to be it. I want one that has the equal sign. And of course, everything else to work out as well. Okay. So let me see. Let me move this thing over just real quick so we can see what C and D look like. All right. So C and D. We're going to compare it to our work as well. All right. So we don't have the equal sign on these as well. So real quick, these are saying these are saying not equal to, and this one's X. Range is not X, range is Y. So the key might be a little bit off. I think it might be needing, or my answer choices are going to be off. I'm thinking that I need my equals sign. So let's go back. So far we know it's not D for sure. Okay. And it's also not B for the same reason that it's not D. It says range is X, and we know that range is not X. Okay, range is Y. So it's either A or B. So let's see from A and B which other pieces are not correct. Okay, or which ones are the ones that match our criteria over here. So we have all real numbers, that's good. Range, although it does need this equal sign here, I mean, it's still good comparatively to the other ones. My y-intercept, which we got over here, was 0, -4, and then our x-intercepts were -2 and 1 and 0. So everything besides this equal sign and the way we just talked about that, it needing that equal sign, it looks like A might be our answer. Let's come over here and let's compare it with C. Okay, so the domain is saying X, and it's saying all real numbers, so that checks out. It's saying -6. Again, it does need this equal sign, but it still checks out nonetheless comparatively to the others. And then the y-intercept, it has these backwards. That's what it did. The y-intercept we got was 0, -4, and it has these flip-flop. That's why it's not C. And the answer would be A. All right. So now let's keep moving on. Let's come over here and let's look at number 3. Let me grab this down, pull this down, and then we will look at number 3. So number 3, what I'm trying to do is I'm solving it and picking which one of these is the correct answer when it comes to the number line. Okay, so let's go ahead and make some room here. And let's solve it by hand here at the bottom. We have 3x minus 2 is in the absolute value, and it's equal to 1. So when I break this down into 2 equations, because my absolute value is already isolated, this is what I have. And I'm going to have the positive version, and I'm going to have the negative version of what I see on the other side. Now when I add 2, I'll get 3. When I add 2 here, I get a positive 1. So dividing by 3, I get x is 1. Divided by 3, I get x is 1/3. So right now I have 1 or 1/3. Okay, so it looks like so far this is the only one that matches up my signs and whatnot, because everything else has like negatives. But anyway, so let's go ahead and graph it just to make sure. So we have 1/3, and we also have 1. And yes, they would just be like dots, just like you see on right here on option B. And then we have to check them. We have to plug them back into the original equation and check them for extraneous solutions. So 1/3 times 3 is 1, minus 2 is -1, and the absolute value of -1 is 1, which checks out. That's what it should be. Plugging in 1 into my original equation, I'd get 3 times 1 is 1, minus 2 is 1, and the absolute value of a positive 1 is still positive 1. So none of these are extraneous. They both checked out. The answer should be B. All right. So now let's move on down. Let me erase a couple things. And then we will go for, and then we will go for number 4. Okay, so let's move this up now. Whoops. Didn't mean to do that. No worries. Sorry for the delay. Alrighty. Come on. Is there a pause button? Let's see if there's a pause button. Yes, there is. All right, you learn something new every day. There we go. I can pause it, so I'll pause between videos as we go forward now. All right, or between questions. All right, so solve the equation, check for extraneous solutions. Here we go. Our goal is to get this x by itself. So let's isolate our absolute value sign first, okay? So if you are struggling to see what moves over first, I always tell students who struggle with this is to imagine that their body is where x is at. And what would be done to you normally, PEMDAS wise, okay? So you would be multiplied by 2. Then that answer would then be subtracted by 4. And then from there, because of PEMDAS, you would be multiplied by this 3. So I'm just going to put it like this. And then the fourth step from there, you would be subtracted by 8. And that's how you would get to a negative 2. All of these would, in normal forward order, PEMDAS wise, this is what would happen. So if you struggle as far as which one do I do first to move over there to the other side with negative 2, I would list them out and then do the backwards opposite. Okay, so the backwards opposite meaning from here, so 2x minus 4, if I'm trying to get x by itself, I'm going to do the backward opposite. So I'm going to add 8 to both sides. And you see that will get rid of this on this side. So you have 3, absolute value of 2x minus 4, negative 2 plus 8 is 6. And the next thing, instead of multiplying, we're going to divide by 3. Because when I divide by 3, there's a cancellation of 1. And I'm left with 2x minus 4 is equal to 2. Again, this is an absolute value. And now I've isolated my stuff. That's just to help you out as far as getting absolute value by itself. The rest is going to still be the opposite, but we have to make sure that once we've isolated these absolute value symbols or symbol, that we're going to break it up into 2 equations. Both of the absolute value pieces are going to be written out just like normal. And then we're going to do what we see and the negative form of what we see on the other side. Now, here's where these other things come into play. Adding a 4 to both sides gives me 6, and then dividing by 2, because we're doing the backward opposite, would give me 3. Okay, and then over here as well, we're going to add 4. So negative 2 plus 4 would give me a positive 2. And then again, dividing by 2 is going to give me a 1. So right now, it looks like 1 and 3 are the answers that we got algebraically. Okay, and yes, it's not an interval, so there aren't any shading as far as in between these going on, because my original one was equal to. Okay, and then when it's equal to, we know that it's going to just be 2 points. So it could be either 0 answers, 1 answer, or 2 answers, or even possibly infinite answers or no solutions, which no solutions, of course, is the same as 0 answers. We have to check for extraneous solutions. Okay, so let's plug these into the original equation and see which ones work and which ones don't. So plugging this in, I'll get 2 minus 4 is a negative 2. Absolute value becomes a positive 2. Times 3 is 6. 6 minus 8 is, in fact, negative 2. So 1 works. 3 times 2 is 6. Minus 4 is 2. And yes, 2 times 3 again is 6. Minus 8 is negative 2. So they both work. So you're going to say that this has 2 answers. Okay, so you're going to say x equals 1 and x is equal to 3. If you want to write it just like this, 1 comma 3, that's fine too. Okay, so again, this is not a disjunction or this is not a conjunction because there's no shading going on, but it would be both answers that you would list out. All right, so, and just for instructional purposes, what I'm going to do is I'm going to quickly show you on the calculator how you can check this and what this looks like, because you do have a calculator portion. But again, please make sure that you are doing these, that you can do them both with or without a calculator. So we could say menu 3, 1, and we're going to solve when 3 times the absolute value, oops, the absolute value will look like, so there's a small glitch, no worries. I will reopen this. And let's go pause this for now. Okay, so let's try this again. I had to just reopen that. So menu, algebra, 1 for solve. And we're going to put 3 times the absolute value. So here's the absolute value key of 2x minus 4. Minus 8. When is it equal to? Notice where the equal sign is, right there, right below control, is negative 2. Now, comma x, we have to tell it what to solve for, so we do comma x. And sure enough, you see x is equal to 1 or 3, which is what we got here. Again, this is not to replace your learning. This is to help you as far as making sure that you understand how to use both by hand and to check it with the calculator, okay? So again, just because I showed you with the calculator does not mean that you're going to be able to use that per se for this particular type of question on the test. But for other ones that you could use it for, yes, by all means, I want to make sure that you understand how to use it. All right, so now let's go over to, let me erase all of this, our last question for this video, number 5. All right, so number 5 is saying solve the inequality. Oops, no, that was for number 6. It looks like I accidentally copied that for number 6. So solve the equation again and check for extraneous solutions. So it's looking basically for the same thing that number 4 was looking at. All right. So again, if you have trouble, list it out in PEMDAS order, what would be done to you here, and you can get X all by itself in that regard. But this one's not too bad. This one's not all that involved with the absolute value sign side as far as getting that absolute value sign all by itself. All we have to do is divide both sides by a 4. Okay, so we'll say 3 minus 6x. So each of these are divided by 4. So we'll get this. Okay, whoops. Each of them are divided by 4. So we'll get 1/2 x and we'll get plus 1. So from here, we're going to break it down since we isolated the absolute value to the positive and negative forms of what we see. Okay, so let's copy it down. First of all, our absolute value piece. So 3 minus 6x on both of them. And then sure enough, we're going to do the positive form of what we saw and the negative form of what we saw over here. So we have 1/2 x plus 1 and 1/2 x plus 1. Again, the positive and negative version. So the positive, it doesn't really do anything because you're not distributing a different sign. It just stays the same. But this negative is what it's all about. This is why we do this step. Because especially this one right here, most people forget this, that it's going to distribute all the way also and get a negative 1. So now what we have left over are 3 minus 6x and 3 minus 6x. Now it's just a matter of getting our x's together. Okay, so let's add 7 or 6x to this side. So we're going to end up having 3 is equal to 1/2 x plus 6x plus 1. If I subtract the 1 over, I get 2 is equal to 1/2 x plus 6x. And yes, adding these together, it's just saying like, what's 1/2 plus 6? Now with fractions, when you're adding them, they must have a common denominator. Right now it's 1. So I need to multiply by this by a form of 1, which is 2 over 2. So that now I have 12 over 2, which is the same as 6, and 1/2, because I need common denominators. So we have 13 halves over here, x is equal to 2. And then over here, same thing, but this time it's a negative 1/2. So it's like taking a negative 1/2 and we're adding 12 over 2 since we moved that over. And a negative 1 plus 12 is a positive 11. So I'll get an 11/2 x. And yes, by moving this 1 over to the other side, we'll get 4 because we get 3 plus 1 because we moved it to the other side is 4. And then last but not least, just to clean it up, I'm going to multiply by the reciprocal. So it's like taking this fraction and just finding the reciprocal, which is just the flip. And you're doing this to both sides. So 2 times 4, or 4 over 1. This one's going to be 8 over 11. And then doing the same thing over here, multiplying this by 2 over 13. Some people divide by 13/2. I think that's a little bit weird to see, especially when you're over here. So that's why I'm just multiplying by the reciprocal because it's easier just to see that this would cancel to this to a form of 1. This would cancel to this to a form of 1. And now you have 2 over 13. You have 2 times 2 is 4. And 13 times 1 is 13. So we have 4/13 and we have 8/11. Okay, so let's go ahead and check for extraneous solutions. This one's going to be a little bit more involved, especially if it's a non-calculator portion of the test, because you have a lot of fractions going on. But as of right now, we have 8/11 and 4/13. Okay, and just so you know, if you wanted to see which one's higher, I don't even know which one's higher because these are weird fractions. You can always multiply like 13 and 8, which is 104. And then you can multiply diagonally across up and get 44 here. So actually, 11 times 4 is 44. 13 times 8 is 104. So I have these backwards. This one, since I got 104 by multiplying diagonally up, 8/11 is actually bigger. Okay, so then I can quickly just write 4/13 to be on this side, if you will. Just quick FYI, that's just a side note of how you can see which ones are smaller versus which ones are bigger for these weird type of fractions. Okay, so plugging it back into the original equation, we can check for extraneous solutions. So 6 times 24, I mean, there's a lot of math going on for sure, but you're going to plug that in and see what you get on the left and see if it equals to what you get on the right. Okay, so let's do that so that you can see some by hand multiplication practice with fractions so that you're ready for the test if you have a question similar to that. So 4/13 times, again, we're plugging this back into the original equation, times 6 is going to be 24 over 13. It's going to be 3 minus this. So again, if I'm going to do this, I need common denominators. So I need to multiply this by a form of 1, which is 13 over 13. So I have 39 over 13 because I have a common denominator. And 39 minus 24 is going to be 15. All right, so we'll have 15 over 13 absolute valued is still 15 over 13. Then we'll multiply it by 4, and we'll finally get 60 over 13 for the left side. Now, if I plug this into the right side, where x is at, I'll get 2 times 4/13 is 8/13. And if I add 4, which is what I'm doing over here to check my answers to see if it's equal to, I need to multiply by a form of 1. Okay, because now I have common denominators, and 4 times 13 is 52, and 52 plus 8 is 60. And sure enough, these equal each other. So 4/13 is not extraneous. Okay, for the sake of time, I'm going to let you do that to check for 8/11. But for the sake of time, I'm going to go ahead and use the calculator to see what it is as far as whether it's extraneous or not. Okay, so let's go ahead and go to the calculator. So we'll do menu, 3 for algebra, 1 for solve. And we're going to do 4 times basically the equation. The absolute value of 3 minus 6x is, kick out, equal to 2x plus 4. We're going to solve for x. And sure enough, we get 4/13 and 8/11. They both showed up, so they're both answers. Neither of them are extraneous. So you can say x is 4/13. And like they said here, or, I know that you're used to seeing or as like a disjunction, but this isn't a disjunction. It's saying either or is the answer. Basically, it's saying that you have 2 answers. So the way I want you to write it out is just x is equal to 4/13, x is equal to 8/11. Or yes, if you want to save a little bit of time and just write them out like this is totally acceptable as well. All right, so those are the first 5 problems of the review.